Alright, in this little, we're starting rotational motion now, and one of the little things that you've got to know about, and you should already have learned in year 12 in mathematics, is radians. Now the whole point with radians, this is really quite badly done, but we'll get the idea, is that you've got a circle, and someone said, what would happen if we had the arc length equal to the radius? Wouldn't that be a convenient angular measure? And I agree, it would be. And we know that we've got, if it's equal to the radius, then we know that there are 2 pi radii in 360 degrees. Right? Now 2 pi, what's that? Well, 2 pi. That gives you an idea how many of these things there are in a full circle. 2 pi would be about 6.28. So whatever it is, if we measure the 360 degrees by 2 pi, we'll get a bit of an idea how many there are. And so 360 degrees is divided by 6.28 comes out at about 57.3. So each radian, 1 radian, equals approximately 57.3 degrees. So they're just a really big unit. So if you've got radians and you want degrees, you just multiply by this 57.3. Okay? And if you've got degrees and you want radians, you just divide by that. If you want to be more specific, you can go to the whole 2 pi thing, and that will give you a better measure. Very nice though thing with this whole radian business is the fact that, and we're going to use it a lot with our angular work, is that if you've got an angular distance and you multiply it by the radius, then you will get the distance. What I mean by that is, no matter how big your circle is, we've got a bigger circle here, and we've got a certain angle, theta, and we've got a certain r. If we want to know this distance here, see this might only be half a radian, then that half a radian times that radius will give us that distance. So this is our first angular formula, which says r theta equals d. It's our first little angular measurement.